Okay, I want to go ahead and show how to solve absolute value inequalities just by doing some examples. I'm going to do it by graphing. Here's our first example. A lot of books show how to solve this algebraically. I actually think it's easier to do it graphically. So I'm going to graph the left-hand side in blue, the absolute value in blue, and the right-hand side in red, y equals 8 in red. There are my two graphs, a v for the absolute value, of course, and a horizontal line for y equals 8. And what we want is we want to know when is the blue graph less than 8. We want to know when is the blue graph under the red graph, pretty much, which is that part of the graph. That bottom part of the V is the part we care about. And of course, we're looking for X. So realistically, it's the domain questions we're asking for. What X's make that true? And then it's important to figure out where they intersect, right? Where in the world do we intersect these guys? So to find that actually happens at the place where the absolute value actually equals 8. That's where it's going to intersect. If we solve this inequality, this equality right here, we end up with two equations, this guy or this guy. And when we solve it, we get two answers, either x equals 1, right here, or x equals negative 13/3, a little bit less than negative 4. And that actually tells us what our answer is. It's between negative 13/3 and 1. That would be the answer to solving this inequality. So that's example 1. Let's do another example. This is going to be a little different. I changed the inequality sign around. You could go ahead and graph the left-hand side and then the right-hand side, but I'm going to go ahead and subtract 1 from both sides first, just because you can. And it's easy and just simplifies the problem. So we end up with this, because 2 minus 1 is 1. I'm going to graph the absolute value and I'm going to graph the y equals 1. But this time I care about it being greater than or equal to. So I want the absolute value to be greater than or equal to 1, which is this part of the graph. And so we want to know when is the blue graph above or equal to the red graph. And that corresponds to those guys right there, those domain elements. So the solution is x is less than or equal to 2, that's this guy, or x is greater than or equal to 4, that's that guy. And if you want to write it in interval notation, it looks like that. So that's how I solve inequalities. I always solve them by graphing if possible.